I think she killed the stream with her paw. I really do. She actually pressed the space bar. I guess I deserve it. I guess I deserve it. That's what I get, huh? Options flows aren't really useful in my opinion. What organ system? Nibbles. Poor Nibbles. I'm definitely not allowed to live in Manhattan, but I have a wonderful apartment. I haven't really used TradingView's other tools. I mean, I tried. I'm a TradingView like Premium Pro Plus super subscriber, and it just kind of sucks. That's just my 2 cents. We have 50 people from Indonesia on Dr. Group right now. Indonesia, Philippines, Argentina. It's so funny. I don't follow TOST. League of Legends. Weeble. I have a lot of programming to do. Gotta get to 1800. Let's go. Actually want to swap this around. Whoa. Do I believe in aliens? No, I don't. Why would I bet something valuable for something that's not valuable? Doesn't make sense. French defense. Budapest. I'm a pest with the Budapest. Hey, look what I found. My dude. Hey, no more pawns. It wasn't on LinkedIn, that was on Gmail. SOD1's been around a long time. PayPal earnings call, maybe. Let me see here, should I just take that? I have to. I said this guy keeps asking about TradingView. I said I don't, I've tried it, it's not good. What the heck? Okay. Hanging pawn right there. Kinda has to go there. Oh, I should just do something like this. This is a really nice trap, I think. Could be wrong. Let's see. You can come here. Check here. No, that doesn't work. Kind of has to take it. Right tick right there. I play chess in prison sometimes. Oh, is he nuts? Career path for Albanians, same career path for everyone else. Not like it's special for Albanians. Why would it be different? Yeah, there weren't too many brilliant people in prison. Hi everyone. What should we do? Want to take a look at Python? Like beginner Python? Think that'd be fun? Wordle? Good idea. You have to email Lex. I hate podcasts. It's just a waste of time. Yeah, I got banned again on Twitter. Crazy, right? Censorship. Thought I had a New York Times account. Oh, whatever. Man, got half the alphabet. All right, not bad. But what is it? A glow. Taylor Swift lyric. SDL. A long time ago, maybe. I did watch the Berkshire meeting. SBS got like 25 plus. Come on. Look at Elizabeth Holmes. She's headed off with 12. College, it depends on who you are, what you want, I guess. Some people really just like to learn. Nothing wrong with that. I don't know, Madoff got life. I don't know what his religion has to do with anything. There's so many weird anti-Semitic people on online. So yeah, this is a book that I actually got a couple copies of this for my fellow prisoners to teach them Python. Maybe we can go through it together. What do you guys think? Is that of interest? Not interesting? Interesting? We didn't have PCs in prison, so I would be the compiler or the interpreter of the code. So this book came out in 2021. It's got a lot of typos, to be honest. Let's read. You know, I'm gonna get some coffee, and then I'm gonna teach you guys Python. Does that sound good? Introduction to Python, and make sure you try Dr. Gupta, and tell your friends and family. Dr. Gupta Vet coming today or tomorrow. Big time, I know. I know you have animals like Nibbles, you have questions. Gupta has answers. In fact, Gupta will be introducing you. It won't be Dr. Gupta as the vet, it'll be Dr. McGrath. All right, I'll be right back. Hey, yeah, what? Let's go, jump up. Yeah. We're playing, yeah, what? Whoa. Let's go, give me here. Woo. What? You trying to hide? You trying to sneak attack me? Don't sneak attack me. I'm the master. I'm the master of sneak attacks. I'm 5'10". I kind of need my inhaler though. Gosh darn it. BDE, that's all I gotta say about that. Right, kitty? What? Counselor? Oh my gosh. Oh, I stepped on her. I stepped on you. My parents are retired now. let's read. Let me move this here. Move the camera here. And I'll just add my editorializing, I guess. The power of Python. The Python language is becoming more and more popular, and in 2017 became the most popular language in the world, according to IEEE Spectrum. The power of Python is real. Python is the number one language because it's easy to learn and use. I agree with that. Due partly to its simplified syntax and natural language flow, but also to the amazing user community and the breadth of applications available. So, Python's really important for machine learning and AI and stuff like that, so I think that that's all correct. Depending on your goals, right? It's good for finance too. Yeah, it's not atypical to make motions to like ask a judge to drop charges, but it doesn't mean anything. They ain't dropping shit. I wish that worked. Shit. It's about a 1 in a billion chance. Anyway, let's get back to work. Yes, Angel, it matters quite a bit, actually. Alright, this book is a reference manual to guide you through the process of learning Python and how to use it in modern computer applications such as data science, AI, physical computing, and robotics. If you're looking to learn a little about a lot of exciting things, this is the book for you. It gives you an introduction to topics you'll need to explore more deeply. Python All-in-One for Dummies 2nd edition guides you through the Python language and takes you on a tour through some cool libraries and technologies, Raspberry Pi, robotics, AI, data science, and more, that all revolves around Python. When you work on new projects and new technologies, Python is there with a diverse number of libraries just waiting for you to use. This is a hands-on book with examples and code throughout. You are expected to enter the code, run it, and modify it to do what you want. You don't just buy a robot, you build to understand all the pieces and make the sense of the way Python works with the robot to control its motors and sensors. AI is complicated, but Python makes a significant part of it accessible. Data science is complicated, but Python makes you do data science more easily. Or helps you, I should say. Robotics is complicated, but Python gives you the code that controls the robot, and Python even enables you to tie these pieces together and use, say, AI and robotics. In this book, we'll take you through the basics of the Python language in small, easy to understand steps. After we have introduced you to language, we will step into the world of AI, exploring programming in the machine learning and neural networks using Python and TensorFlow. TensorFlow is a very important Google library, which is open source, but I believe Google created it. And it's a really crucial AI tool. All right, let's keep going. And working on real problems with real software, not just toy applications. After that, we're off to the exciting world of big data and data science with Python. We'll look at big public data sets such as medical and environmental data. Finally, you get to experience the magic of what we call physical computing. Using the small, inexpensive, and incredibly popular Raspberry Pi computer, we show how to use Python to control motors and read sensors. This is a lead up until the final mini-book, Building Robots, where you build a robot and control it with Python and your own programs, even using AI. This is not your mother's RC car. Python data science, robotics, AI, and fun all in the same book. This book won't make you understand everything about these fields, but it will give you a great introduction to the terminology and the power of Python in all these fields. Enjoy the book and go forth and learn more afterwards. So anyway, like I said, I got this book for a bunch of my prisoner pals. One of the prisons I was in wouldn't let me actually get the book. So I bought a number of copies, but they wouldn't actually even let me bring it into the prison, which is crazy, right? I think for like $30 or whatever this book is cost, it's worth like $1 million of net present value to your life, possibly, if you want to learn Python, because it's a good book and it actually does go through some pretty complicated things, believe it or not. So I strongly recommend you download it, buy it, steal it, do whatever you have to do. Foolish assumptions. This is why. We assume that you know how to use a computer in a basic way. If you could turn on the computer and use a mouse, right? You're ready for this book. We assume that you don't know how to program yet, although you will have some skills in programming by the end of the book. If we're wrong and you already know Python or some other computer programming language, jump ahead to mini book 4 and dig right into learning something new. It's called Python for Dummies. Our intent is to guide you through the language of Python and then through some of the basic technologies and devices that use Python. We provide concrete examples. If you get stuck on something, look it on the web, read the tutorial, and come back to it. You need a Raspberry Pi 3 billion plus 3B plus starter kit or Raspberry Pi 4B starter kit. In addition, you'll need these items. We're just going to skip through some of this. Where to go from here. This book is designed so that you can read a chapter or section out of order, depending on what subjects you're most interested in. Where you go from here is up to you. Book 1 is a great place to start if you've never used Python before. Discussing the basics and common terminology can be helpful when reading later chapters that use terms and commands regularly. Okay. Chapter 1, Getting Started. Contents at a glance. Okay. Is this like section 1 or chapter 1? Let's see. Or it's section 1, Getting Started. So chapter 1, starting with Python, why Python is hot, choosing the right Python, tools for success, writing Python in VS Code, using Jupyter Notebook for coding. We're going to discover why Python is hot, finding the tools for success, and the other two things I just mentioned. Okay, so because you're reading this chapter, you'll probably realize that Python is a great language to know if you're looking for a good job in programming, or if you want to expand your existing programming skills into exciting, cutting-edge technologies such as AI, ML, data science, or robotics, or even if you're just building apps in general. So we're not going to try to sell you on Python. It sells itself. Our approach leans heavily towards the hands-on. A common failure in many programming tutorials is that they already assume you're a professional programmer in some language, and they skip over things they assume you already know. This book is different. We don't assume that you know anything about programming in Python or any other language. We do assume you can use a computer and understand basics such as files and folders. We also assume you're not up for settling down in an easy chair in front of a fireplace to read page after theoretical stuff after Python, like some kind of boring novel. You don't have that much free time to kill. So we're going to get right to it and focus on doing, hands-on, because that's the only way most of us learn. We've never seen anyone read a Python book and then sit on a computer and write Python like a pro. Human brains don't work that way. We learn through practice and repetition, and that requires being hands-on. Okay. Why is Python hot? We promised we wouldn't spend a lot of time trying to sell you on Python, and that's not our intent, but we'd like to talk briefly about why it's so hot. Python is hot primarily because it has all the right stuff for working on the kind of software development that's driving software development world these days. Machine learning, ML, robotics, AI, and data science are the leading technologies today and for the foreseeable future. This is written before ChatGPT. Python is popular mainly because it already has lots of capabilities in these areas, while many older languages lag behind these technologies. Just as there are different brands of toothpaste, shampoo, cars, and just about every other product you can buy, there are different brands of programming languages, with names such as Java, C, C++, and C#. They're all programming languages, just like brands of toothpaste are toothpaste. The main reason cited for Python's current popularity is Python is relatively easy to learn. I would completely agree with that. Everything you need to learn and do Python is free. Well, that's typical of most languages. Python offers more ready-made tools for current hot technologies, such as data science, machine learning, AI, and robotics, than most other languages. That's definitely true. I disagree with this part a little bit. HTML, CSS, and JavaScript. Some of you may have heard of languages such as HTML, CSS, and JavaScript. Those aren't traditional programming languages for developing apps or other generic software. HTML and CSS are specialized for developing web pages. And although JavaScript is a programming language, it is heavily geared to website development and isn't quite in the same category of general programming languages such as Python and Java. I'm rolling my eyes there. If you specifically want to design and create websites, you have to learn HTML, CSS, and JavaScript, whether you're familiar with Python or some other programming language. Anyways, Figure 1.1 shows Google search trends for the last 5 years. As you can see, Python has been gaining popularity, as indicated by the upward slope, whereas other languages have stayed the same or declined. This certainly supports the notion that Python is the language most people want to learn right now and for the future. Most people would agree that given the trends in modern computing, learning Python is the best opportunity for getting a secure, high-paying job in the world of information technology. You can do your own Google search trends at trends.google.com. Choosing the right Python. There are different versions of Python roaming out in the world, prompting many a beginner to wonder things like, why are there different versions? How are they different? Which one should I learn? All good questions, but we'll start with the first. The version is kind of like a car year. You can go out and buy a 1968 Ford Mustang,
a 1990 Ford Mustang or a 2019 or 2020 Ford Mustang, but they're all Ford Mustangs. The only difference is that the one with the highest year number is the most current Ford Mustang. That Mustang is different from the other models, and that has some improvements based on experience with earlier models, as well as some features current with the times. Programming languages and most other software products work the same way, but as a rule, we don't ascribe year numbers to them because they're not released on a yearly basis. They're released whenever they're released. But the principle is the same. The version with the highest numbers, the newest, most recent model, sporting improvements based on experience with earlier versions, and features relevant to the current times. Just as we use a decimal point with money to separate dollars from cents, we use decimal points with version numbers to indicate how much the software has changed. When there's a significant change, the entire version is usually changed. Most minor changes are expressed with decimal points. You can see how the version numbers changed according to the year in Table 1.1, which shows that release dates of various Python versions. We skipped a few releases because there is little reason to know or understand the differences between all the versions. We present the table only so you can see how the newer versions have higher version numbers. That's all that matters. So you can see Python 3.9 was released in October 2020. Python 2.7, though, was July 2010, but Python 3 was before that in December 2008. If you paid close attention, you may have realized that 3.0 starts in December 2008, but 2.7 was 2010. So versions are like car years. Why the overlap? The car years analogy just indicates that the larger the number, the more recent the version. But in Python, the year is the most recent within the main Python version. When the first number changes, that's usually a change that's so significant, software written in prior versions might not even work with that version. If you happen to be at a software company with a product written in Python 2 on the market and have millions of dollars invested in that product, you may not be too thrilled to have to start over from scratch to go with the current version. So older versions continue to be supported and evolve independent of the most recent version to support developers and businesses that have already invested in the previous version. The biggest question on most beginners' mind is, what version should I learn? The answer is simple, whatever's the most common version. You'll know that when you go to python.org to download Python, which I recommend you do right now in a separate window. It will tell you the most current stable build or version. That's the one they'll recommend, and that's the one you should use. The only reason to learn something like version 2 or 2.7 or something else older would be if you've already been hired to work on some project or in a company requires you to learn that version. That situation is pretty rare because as a beginner you might not already have a full-time job as a programmer, but in the real world some companies are invested in that version of a product, so when they're hiring they'll look for people who know that version. In this book we focus on versions of Python that are current late in 2020 or early 2021 from Python 3.9 or above. Don't worry about the first and second digits. Version 3.9.1 is similar enough to version 3.9.0 that it's not important, especially to a beginner. Version 3.9 isn't that big of a jump from 3.8, so don't worry about these minor differences. Most of what's in Python is the same across all the versions. So you don't need to worry about investing time learning a version that is or will soon become obsolete. All right, how about some tools for success? Now we need to get started, get your computer set up so you can learn and do Python hands-on. For one, you'll need a good Python interpreter and editor. The editor lets you type the code, the interpreter lets you run the code. When you run or execute the code, you're telling the computer to do whatever my code tells you to do. The term code refers to anything written in a computer programming language that provides instructions to a computer. The term coding is often used to describe the act of writing code. A code editor is an app that lets you type code in much the same way that an app such as Word or Pages lets you type regular plain English text. Just as there are many brands of toothpaste, there are many code editors that work well with Python. There isn't a right one or a wrong one or a good one or a bad one or a best one or a worst one. Just a lot of different products that basically do the same thing, but vary slightly in their approach and what the editor's creators think is good. If you've already started learning Python and you're happy with what you're using, keep using it. But if you're just getting started, we suggest, and Martin Shkreli suggests, you use VS Code because it's an excellent free learning environment. Okay. Introducing Anaconda in VS Code. The editor we recommend and we'll be using this book is called Visual Studio Code, but most often it's called VS Code. The main reason is it's an excellent editor for learning coding. It's an excellent editor for writing code professionally. It's used by millions of professional programmers and developers, including us over at DL Software. It's relatively easy to learn and use. It's pretty much the same on Windows, Macs, and Linux, and it's free. The editor is an important part of learning and writing Python code. So you also need, though, a Python interpreter. Chances are you're going to want to also want some Python packages. Packages are simply code. This is very important. Packages are simply code written by someone else to do common tasks that you don't have to start from scratch and reinvent the wheel every time you want to perform one of those tasks. Python packages are not a crutch for beginners. They are major components of the entire Python development environment, and they're used by seasoned professionals as much as beginners. Historically, managing Python, the packages, and the editor was a somewhat laborious task involving cryptic commands at the command prompt. That's not a particularly bad thing, but it isn't the most efficient way to do things, especially when you're first getting started. You end up spending a lot of time up front trying to learn and type awkward commands just to get Python working on your computer rather than learning Python itself. An excellent alternative to the command line is using a Python integrated development environment with a more intuitive and easily managed graphic user interface, such as Anaconda. It's free and excellent. If you've never heard of it before, go to anaconda.com, and again, I recommend you download it. I've got Anaconda installed myself. Anaconda is often referred to as a data science platform because many of the packages that come with it are data science oriented. But don't let that worry you if you're interested in doing other things with Python. Anaconda is excellent for learning and doing all kinds of things with Python. And it comes with VS Code, our personal favorite coding editor, as well as Jupyter Notebook, which is another excellent means for learning to code with Python. And best of all, it's 100% free, so it's well worth downloading it and installing it. So go ahead and do that in VS Code. And I'm going to skip the part of the book that talks a little bit about how to install. I assume y'all know how to do that. And you could take this time to continue installing Anaconda in VS Code. Go ahead, I'm watching you. Writing Python in VS Code. Most of the Python coding we do here we'll do in VS Code. Whenever you want to use VS Code to write Python, open VS Code from Anaconda instead of the start menu. This way VS Code will already be pointing to the version of Python that comes with Anaconda, which is easier than trying to figure that all out yourself. So open Anaconda Navigator, and then I guess there's a VS Code. Let me see if that's here. And then we're going to talk about Git. Lots of different tools here, but you need to learn them all if you want to be a pro. Git is a way to store backups of your coding projects and share coding projects with other developers or team members. It's popular with professional programmers, and VS Code has built-in support for it. But Git is optional and not directly related to learning Python, so it's perfectly okay to choose don't show this again. But you can install Git whenever you want later, which I recommend you do. All right, so I'm just launching this real quick. Thanks for following, David. This is called the Anaconda Navigator. I don't actually use this a lot, but we'll use it now. And let's see if there's, I think there's supposed to be a VS Code thing here somewhere. I see VS Code. Here's VS Code. All right, launch. Hit the launch button. And we launched it. Let's see what the book says. The first time you open VS Code, you may be prompted to make some decisions. You could just click X on each one. When you're finished, the library or the window will look something like this. Your screen will be black. In this book, we show everything in white. You can change that in the menu. Visual Studio Code is a generic code editor. It works with lots of different languages, so it's good to get some extensions, though, for Python and Anaconda. So we can click the extension page. Here it is on the left here. You can actually see different kinds of extensions. I have a lot of ones for JavaScript because that's kind of like my primary thing. But let's see if I type in Python, what happens. All right, I have the Python one installed. And let's see if I got Anaconda. Oh, this one's Anaconda Terminal. I don't think that's what I want. I guess we should install YAML. Alright, so I think we have... I have a lot of extensions installed, I guess, but... let's see here. Make sure I have this one installed too. It's a little weird I don't have the Anaconda thing installed. Well, it is what it is. Alright, it's choosing your Python interpreter. Go to View Command Palette. View Command Palette. That's Control-Shift-P is a lot easier. And then type Python. And then type Select Interpreter. And there's a bunch of ones to choose from. I see Python 10, Python 11, 3.10, 3.11. I suppose we can try the most recent one, right? But it also wants me to maybe try the one that says Conda as base. So this is 3.9.12. It doesn't really matter which one you use, I think. We'll use the Conda one. Okay, writing some Python code. So we're going to click View, and then I guess Terminal, which is Control tilde or Control backtick. And here we have the terminal. So we can type Python and hit enter, and we're in this something called a REPL, R-E-P-L, read, evaluate, print loop. And let's see, we could type 1 plus 1, and we get 2. We could type 1 plus 3, we get 4. We could do 3 to the 4th power, that's 81, because 3 times 3 is 9, times 3 is 27, times 3 is 81. Okay, so all this seems to work. Okay. We can exit this way and many other ways. Cool. Now using Jupyter Notebook for coding. Interesting. Jupyter Notebook is another popular tool for writing Python code. The name Jupyter comes from the fact that it supports 3 popular languages: Julia, J-U, Python, P-Y-T, and R, Jupyter. Cool, huh? Julia and R are popular for data science. Python is a more generic programming language that happens to also be popular in data science as well, but Python is good for all kinds of development, not just data science. The notebook part of the name comes from the fact that your code is placed in structures similar to a regular paper notebook. People often use Jupyter to share code on the internet. It's free and it comes with Anaconda. So let's go to Anaconda and click Launch under Jupyter. Where is Jupyter? There it is. Well, there's Jupyter Lab and then there's Notebook. Let's try Notebook. All right, it opened a little web page here. And I think I can click New and hit Python 3. Here we go. So it looks like, basically looks like this. Jupyter notebooks are web-based. So when Jupyter opens, it does so in Safari, Chrome, Edge, Firefox, or IE. At first, it doesn't look like it has much to do with coding, but you have to open the notebook up. So now you'll see this in brackets with a colon. This is called a cell. and a cell can contain either code or regular text and pictures. If you want to write code, make sure the drop-down on the toolbar displays code. Change that menu option to Markdown if you want to write regular text. Markdown is language for writing text that uses fonts, pictures, and such. We'll talk more about that in the next chapter. For now, let's stay focused on Python code, because that's what this book is about. A cell is not like a Python interpreter where your code runs immediately. You have to write some code first, and then run the code by clicking the Run button in the toolbar. Let's click inside this, type 1 + 1, and hit Enter. Nothing happens. To get the result, we have to click Run. And then we see the output. Input 1 + 1, output 2. I actually don't see the run this cell. Mad lad. Okay. So that's how you start Jupyter. Okay, so the extension is IPYNB. The PYNB part is short for Python Notebook. The I is IPython, which is the name of the app from which Jupyter Notebook is created and is short for interactive. So you have a great set of tools for learning Python. We're all set up. The simple skills you've learned in this chapter will serve you well as your professional programming after you've mastered the basics. Let's go to chapter 2 now. I'm glad you all have set this up with me and we're ready to learn Python. All right, chapter 2, using interactive mode, creating a development workspace, creating a folder for your code, typing, editing, and debugging code, and writing code in Jupyter. Interactive mode, getting help, and writing apps. Now that you've installed Anaconda and VS Code, we're ready to start digging deeper into writing Python code. In this chapter, we'll take you through the interactive help and code editing features of VS Code and Jupyter to build on what we've learned so far. Most of you are probably anxious to get started on more advanced topics such as data science, AI, robotics, or whatever, but learning those topics will be easier if you have a good understanding of the tools and the skills to use them. Using Python's interactive mode. Many teachers and authors will suggest that you try things hands-on at the Python prompt and assume you already know how to get there. We've seen many frustrated beginners complain training activities recommended never work for them. The frustration often stems from the fact that they're typing and executing code in the wrong place. With Anaconda, the terminal pane in VS Code is a great place to type Python code. So in this chapter, let's go there. And again, you can press Control backtick and it just comes up. Or you can click Terminal, New Terminal, lots of different ways to do it. So let's type Python version, and you'll see it's Python 3.912 here. Let's see if I can. I wrote the code for Dr. Gupta's business logic, and my colleagues wrote the infrastructure. What's up, Halfrich? We did just get started. All right. So that's how we look up the Python version number. If you're getting an error message, let me know, because that's not what's supposed to be happening. This should be pretty easy. So if we type Python, we'll get into the Python interpreter. Here it says some stuff about Anaconda. Make sure you press enter. PyLint is a feature of Anaconda that helps you avoid code. Sometimes that's called linting. So if you want to install PyLint, you're welcome to do that. So now again, we type Python in and we have this prompt. This again is called the REPL, read, evaluate, print loop, REPL. All right, so if we try to type howdy or something like that, we get an error, right? Howdy is not defined. The interpreter doesn't understand what we mean, but you can't break anything. So you can type that and you'll see some gibberish that tells you it doesn't know what howdy means, but nothing is broken. You can just keep trying again and again. Now let's try to use help. If we type help, we get another error message which says type help with parentheses. So I'll do that, and you get a bunch of different help messages here. And they mention there's a tutorial with a link there. And we could also enter some keywords here in this help mode. So we're kind of in this weird help mode at the moment. So we can type keywords. That's a good idea. I spelled it wrong. There we go, keywords. These are all the keywords in Python. It's actually a very small amount if you look at it, and you can memorize every single one of these, right? That's not very much at all. Imagine a language with only, like English or French or something like that, with only, what is this, 1, 2, 3, 4, 1, 2, 3, 4, 5, 6, 7, 8, 9, 36 words. That's very, very few. Pretty cool, right? So I guess we could try like class, a class definition. This is pretty complicated. We don't have to worry about that right now. Just press enter until it's done. And we left the Python help interpreter by just continuing to hit enter over and over again. You could also press Q or Control Z. And of course you can Google or go to Stack Overflow or something like that. YouTube is also pretty good for learning Python. Okay, so creating a Python development workspace. We want to create apps, right? So this terminal is not good enough for that. So we found that creating apps is easiest if you set up a VS Code development environment specifically for learning and coding Python. You can set up other development environments in other languages, such as HTML for the web, fine-tuning each as you go to support whatever language you're working in. We often switch between Mac and Windows computers, so we have one development environment for each. One of the authors has a OneDrive folder. In another way to do it is to have your environment on your hard drive rather than a cloud drive. VS Code uses the term workspace to define what we'll call a development environment. The development environment is the Python interpreter you're using plus any extensions you gather along the way. So you can launch it from Anaconda, and then we can say file, save workspace as. So I'm not going to actually do that because I don't think it's that important. And you can choose different settings and stuff like that. And you can also edit the settings and stuff like that. Create a folder for your Python code. That's up to you guys. I just have a folder on my machine called code. Okay, let's create a Python file. So we're just going to hit File, New File, and I click Python, and I can type in, this is a Python file, and I can save it. And let's see, I can save it here. And I can call it hello.py. And you can see this is the file name. This extension is always p.py. Print hello world. And if we want to run this file, so I've saved it, and let's say we want to run it. We can right click, let's see, open folder. Right click and run Python file in terminal. And it's running it, doing all kinds of magic, and you can see the text hello world came out. I can go change this text to say, hello YouTube. Hello YouTube stream. And if I press the same stuff, run Python file in terminal, it'll say hello YouTube stream. So this is a one-line computer program, and it'll be, for some of you, this will be your first computer program ever. Hello YouTube stream, how are you? Again, this will work. And if this is your first computer program, congratulations. You're a programmer now. This app is not the most exciting one in the world, but at least now you know how to write, save, and execute a Python program in VS Code, a skill you'll be using as you continue through this book and throughout your Python career. Okay, when you're first learning to write code, you're bound to make a lot of mistakes. Making mistakes is no big deal. You won't break or destroy anything. Your code just won't work as expected. Before you attempt to run some code, you might see several screen indications of an error. The name of the file will be in red in Explorer. That's a really nice thing about VS Code. The number of errors will be in red next to the file name. The number of errors will appear with a circled X, and the bad code will have a wavy red underline. So if we try to do print in capital letters, you'll see that wavy underline there, right? You can't do that in Python. It has to be in lower cases. There's also a debugger. So this is a little more complicated. Let's click debug. So with debug, we'll have a bunch of options at some point that could come in handy down the road. So let's go to the Jupyter notebook this time. Same concept of saving and whatnot in Jupyter. I used Control Enter. I held Control and pressed Enter to get the output. But I could also have clicked Run. You can also do Alt-Enter. So, Markdown text. I guess they don't want to teach Markdown right now. But we can do a little bit of Markdown if we click Markdown. Hashtag Markdown text, or we could just say, hello everyone. These are just comments and not code. And we could even put photos and stuff like that. And if we click run, nothing happens, right? There's nothing to run in Markdown. It actually gets formatted a little, but there's nothing special that's going on there because it's not code, it's Markdown. All right, so now we're going to finally get started in writing some more code. Chapter 3. We're understanding the Zen of Python, introducing object-oriented programming, discovering why indentations are important, and using Python modules. So this will be a lot of fun. I am an alien, it's true. Python elements and syntax. We're getting started here. Many programming languages focus on things that the computer does and how it does them, rather than the way humans think and work. This one simple fact makes most programming languages difficult for most people to learn. Python, however, is based on the philosophy that a programming language should be geared more towards how humans think, work, and communicate than what happens inside of a computer. The Zen of Python is a perfect example of that human orientation, so we'll start the chapter with that topic. The Zen of Python is shown in Figure 3.1, and it's a list of the guiding principles for the design of Python. The principles are hidden in the Easter egg, which is something in a programming language that's not easy to find, and it's an inside joke. But to get the Easter egg, go to the terminal, type in Python, type import this, and you'll get a list of these aphorisms. Let's read them. The Zen of Python by Tim Peters. Beautiful is better than ugly. Explicit is better than implicit. Simple is better than complex. Complex is better than complicated. Flat is better than nested. Sparse is better than dense. Readability counts. Special cases aren't special enough to break the rules. Although practicality beats purity, errors should never pass silently, unless explicitly silenced. In the face of ambiguity, refuse the temptation to guess. That's a good piece of advice regardless. There should be one, and preferably only one, obvious way to do it. And although that way may not be obvious at first unless you're Dutch. Now is better than never. Although never is often better than right now. If the implementation is hard to explain, it's a bad idea. If the implementation is easy to explain, it may be a good idea. Namespaces are one great honking idea. Let's do more of those. So this is the Zen of Python. Shut up, kitty. The Zen of Python is sometimes referred to as PEP 20, where PEP is an acronym for Python Enhancement Protocols. The 20 perhaps refers to the 20 Zen of Python principles, only 19 of which have been written down. We all get to wonder about or make up our own final principle. Many other PEPs exist, and you can find them all on the python.org website. The one you'll likely hear about the most is PEP 8, which is the style guide for Python code. The guiding principle for PEP 8 is readability counts, that is, readable by humans. Admittedly, when you're first learning Python code, most other code will look like gibberish scribbled down by aliens, and you may not have any idea what it means or does. But as you gain experience with the language, the style consistency will become more apparent. You'll find it easier and easier to read and understand other people's code, which is an excellent way to learn coding yourself. We'll fill you in on Python coding throughout the book. Trying to read about it before working on it is surely to bore you to tears. So for now, anytime you hear mention of PEP or PEP 8, remember it's a reference to Python coding style guidelines from the Python website. And anytime you can search for PEP 8. PEP 8 is also referred to as PyCode style, especially in VS Code. This PEP 8 business can be a double-edged sword for new learners. On one hand, you don't want to learn a bunch of bad habits, only to discover that you have to unlearn them. On the other hand, the strict habits or demands of PEP 8 can frustrate you. So we'll follow PEP 8 as we go along, and you can configure Pylint if you want to help you out with the PEP 8 stuff. I recommend that we don't do that. All right, introducing OOP. That's right. Not OPP, other people's property, but OOP, Object-Oriented Programming. OOP, you know me. At the risk of getting too technical or computer science-y, we should mention that there are different approaches to designing languages. Perhaps the most successful and widely used model is OOP, or Object-Oriented Programming, which is a design philosophy that tries to mimic the real world in a sense that it consists of objects with properties as well as methods, which are actions that those objects perform. So objects have properties like color or size, and then they have methods like push or pull. Take a car, for example. Any one car is an object. Pay attention to this really carefully. Any one car is an object. I'm not learning Python, I'm teaching Python. Not all cars are exactly the same. Different cars have different properties, such as make, model, year, color, and size. Again, pay really close attention. A car is an object, but not all cars are the same. Different cars have different properties. Make, model, year, color, size, and they're different from one another. And yet, they all serve the basic same purpose, to get us from point A to point B. All cars have certain methods, things that they do that are in common. You can drive them, steer them, speed them up, slow them, control the temperature, and more controls in the car that you can manipulate with your hands. Okay, what does that have to do with this? Well, an object is an object-oriented programming language isn't a physical thing. So an object in our programming language isn't a thing like a card, but it exists inside of our computer. It's a software creation. In Python, you can have a class, this is very important, which is you can think of as an object creator, such as a car factory, that can produce many different kinds of objects, like cars, for varying purposes. A sporty car, an off-road car, a sedan. All these objects can be manipulated through the controls that they have in common, much as all cars are manipulated by controls such as the steering wheel, brakes, accelerator, and gear shift. Python is very much an object-oriented language. The core language consists of controls in the form of words that allow you to control all kinds of objects. Again, objects. In your own and other people's programs. However, you need to learn the core language first, so when you're ready to start using other people's objects, you know how to do so. Similarly, after you know how to drive one car, you pretty much know how to drive them all. You don't have to worry about renting a car only to discover the accelerator is on the roof, or the steering wheel is on the floor, or you have voice commands rather than a brake to slow it down. The basic of driving applies to all cars. So we'll learn more about object-oriented programming at some point. QAnon. Discovering why indentations count, big time. In terms of the basic style of writing code, the one feature that really makes Python different from other languages is that indentations, rather than parentheses, curly braces, and so forth, are used to indicate blocks, or chunks of code. We don't assume that you're familiar with other languages, so don't worry if that statement means nothing to you. But if you're familiar with JavaScript, you know that you have to do quite a bit of wrangling with parentheses to control what's in the code. For example, here's some JavaScript code. You see all these parentheses and braces, right? So many parentheses, braces, and semicolons. The code is a mess and not fun to read. We can make reading it a little bit easier by breaking it up into multiple lines and indenting some of these lines. Doing that is not required in JavaScript. Now you can see that the code is a lot more readable, right? In JavaScript, the parentheses and curly braces are required because they identify where the code begins and ends. The indentations are optional. They're up to you for readability. The rules are the opposite in Python. because it doesn't have curly braces or any special characters that mark the beginning or end of code. The indentations themselves mark those. So these indentations, they're not optional, they're required, and they have a huge effect on how the code runs. So when you read the code as a human, not as a computer, it's easy to see what's going on, and you're not distracted by a bunch of quotation marks and all those other things. So here's the same code written in Python. It's only a couple of lines, and it's a lot easier to read. You may have noticed that the top of the Python code starts with import. Lines that start with import are common in Python, and you'll see why in the next section. So it says import random up there. Using Python modules. One of the secrets to Python's success is that it is comprised of a simple, clean core language. That's the part you need to learn first. In addition to the core language, there are many modules that you can grab for free and access from your own code. Those modules are also written in the core language, but you don't even need to see that or know that because you can access the power of the modules from the core language. Most modules are from a specific or for some specific applications such as science or AI or working with dates or time or whatever. The beauty of using modules is that other people spend a lot of time creating, writing, and fine-tuning the module so that you don't have to. You simply import the module into your own Python file and use the module's capabilities as instructed in the module's documentations. For example, we had that Magic 8-Ball program that started with the code import random. Interesting, right? Import random. The core Python language has nothing built into it to generate a random number. We could figure out how to make a random number generator, but we don't need to because somebody else did, and they made the code freely available. So if we start with import random, it tells the program that you want to use the capabilities of the random number generator module to generate a random number. Then later in the program, you can do that with answer equals random.randint18. This is a line of code. Hundreds of free modules for Pythons are available. You just need to know which ones to import in your program. You may be wondering where to find all these modules. Well, they're all over the place online, but you'll probably never need to find and download them because you already have most of the modules, the widely used modules in the world. They're all in Anaconda. So if we open up Anaconda, click Environments, look at all these modules. They're all installed already. One of the nice things about Anaconda is that to get the latest version of these modules, you don't have to do any weird pip commands. Instead, just click the arrow or version number of the module you want to download and click Apply. So I can click here, I think, and click Apply. And this sort of like upgrades it to the latest version. Pretty cool. Anaconda does all the dirty work. All right, so for the syntax for importing modules. You must import a module before you can use it. So you do import module name, and then there's this optional as alias. Code written in a generic format like that, with some parts in italic, some in square brackets, is sometimes called a syntax chart because it's not showing you literally what to type. It's showing you the format or syntax of the code. Here's how information is presented in a syntax chart. The code is case sensitive, meaning you must type import and as using all lowercase letters as shown. Anything in italics is a placeholder for the information that you should supply in your own code. For example, you would replace the module name with the name of the module you want to import, but this is the code you have to type exactly. It's in monospace without italics. Anything in square brackets is optional. So this is optional. And you never type the square brackets. Okay, you can type the import line at any place you type Python code. At the command prompt, in a Py file, in a Jupyter notebook. In a .py file, always put import statements first so their capabilities are available to the rest of the code. Using an alias with modules. You just saw that the import's command syntax, you can assign an alias or nickname to any module you import. just by following the module name with a space, the word as, and a name of your choosing. Most people choose a short name that's easy to type and remember, so they don't have to remember the long name every time they want to access the module's capabilities. For example, instead of typing import random, you could type import random as rnd, which is a shorter nickname. Then you don't have to use the full name random. You could type rnd.randint18. Using an alternative name doesn't seem like a big deal, but some modules are pretty lengthy, and you want to refer to modules in many places in your code. So now we're going to get our hands dirty with real Python code here in the next chapter. This is chapter 4, opening the Python file, using comments, understanding data types, doing work with Python operators, creating variables, understanding syntax, and organizing code. So this is really the first real chapter. So building your first Python application. So you want to build an app in Python. Whether you want to code a website, analyze data, or create a script to automate something, this chapter gives you the basics you need to get started on your journey. Most people using programming languages like Python to create app programs or application programs, which are often referred to as applications, apps, or programs. To create apps, you need to know how to write code inside the code editor. You also need to start learning the language, which is Python. Like any language, you need to understand the individual words so you can start building sentences and finally blocks of code that will enable your app to work. First, we walk through creating an app file in which you'll create your code. Then you'll learn data types, operators, and variables, which are the words of the Python language, and then Python syntax. Along the way, you'll save your app, catch mistakes with linting, comment your code so that you and others can understand how you built it and why. Are you ready? All right, so we're using VS Code. We got our hello.py file. Why don't we use that? There it is. Hello.py. Do you see that? Let's start with a comment. A programmer's comment, or usually called a comment for short, is a text in the program that does nothing. Which brings up the question, if it does nothing or doesn't do anything, why type it in? As a beginner, you can use comments in your code as notes to yourself, so you know what the code is doing. This can help a lot when you're first learning. However, comments aren't just for beginners. When working in teams, professionals use comments to explain to team members what their code is doing. Developers will also put comments in their own code as notes to themselves, so that if they review the code in the future, they can refer to it in their own notes for reminders as to what they did. Because comment isn't code, right? Your wording can be whatever you want, but you have to start with the pound sign or triple quotations. So I use pound for most of my comments in Python. This is a comment in Python. You can also do triple quotes. Hold on. So you can see it'll turn green if that's the right way to do it. So triple, I guess double quotations, like that, and then inside, I don't know, this doesn't seem to be turning green. That's why I only use the hashtag. Well, it says, although we won't use multiple line comments yet, be aware you can type longer comments by enclosing them in triple quotation marks. These larger comments are called docstrings and often appear at the top of a Python definition, which are apps building blocks that you'll learn later on. It isn't necessary to do one yet, but here's an example of a multi-line comment. Yeah, it doesn't have to turn green, I figured that. It'd be nice if it did. At the beginning and end of the comment, you can use 3 single quotations rather than double quotations if you prefer. Comments are usually colored differently. Docstrings are colored brown. Okay, well that's helpful. You can put an unlimited number of comments in your code. If you're waiting for something to happen, don't. When you're working in an editor like this, the code doesn't do anything until you run it. And right now, all we have is a comment, so even if we did run this code, nothing would happen because comments are for human readers, not for computers. All right, let's start with the absolute basics. So right now we're starting programming. So if you haven't listened to anything at all, you're pretty much okay, because all this setting up stuff and tooling stuff is important, but this is the really important part. This is actual programming. Understanding Python data types. Ooh, really exciting. You deal with written information all the time, and probably don't think about the differences between numbers and text. Numbers are amounts, just 10 or 123.45. Text consists of letters and words. For computers, the big difference is that they can do arithmetic, like add, subtract, multiply, or divide with numbers, but not with letters or words. For example, everyone knows that 1 plus 1 is 2. The same doesn't apply to letters or words. The expression a plus a doesn't necessarily equal b or aa or anything else, because unlike numbers, letters and words aren't quantities. You can buy 12 apples at a store because 12 is a quantity, a number. You can't buy a snorkel apples because a snorkel is a thing. It's not a quantity, a number, or a scalar value. I wish I could buy snorkel apples. I would buy those right away. Numbers. Numbers in Python must start with a number digit, 0 to 9, a dot or period, which is a decimal point, or a hyphen, which is used as a negative sign for negative numbers. A number can contain only one decimal point, obviously. It should not contain any letters, spaces, dollar signs, or anything else that isn't part of a normal number. Python has the following rules on table 4.1, which shows good and bad Python numbers. Okay, 1, that's a good number. That's a whole number. It's an integer. 1.1, that's good too. That's a number with a decimal point. 12345.6.89 or 1234567.89. This is a larger number with a decimal point, and again, no commas, really important. No commas allowed. -2, this is a negative number indicated by the hyphen that starts the number. 0.99, this is a number, it starts with a decimal point, and it's less than 1. Okay, here's some bad examples. $199, that won't work. That's not a number in Python. You can't have the dollar sign. 12,345.67, that's also bad. You can't do that. You can't have any commas. We're reading from Python All-in-One for Dummies by John Shovak and Alan Simpson. Okay, here's another number. 11013232. This is bad. It contains a space. No space is allowed. This one looks like a social security number. Like 91740-3384. You can't have that. You can't have a hyphen. Here's the social security number. You can't have 2 hyphens. Here's 123 Oak Tree Lane. You can't have any spaces or letters or words. Here's a phone number. You can't have that either with parentheses and hyphens. And here's an IP address, 127.0.0.1. You can't do that either. No decimal places are allowed. No multiple decimal places. Only 1 decimal point is allowed. If you're worried about the number rules that won't let you work with dollar amounts or zip codes, stop worrying. You can store that kind of information. You'll see that in a minute. But the numbers have to match these 4 or 5 good first examples. 1, 1.1, 12345.6.89, -2, 0.99. If you're looking at the code for more advanced scientific or mathematical applications, you'll sometimes see the E or J. And Python does support a few different types of numbers that we didn't cover yet. So integers are any whole number, positive or negative. No limit to its size. That's really interesting. There are limits in other computer programming languages. Numbers such as 0, -1, or all these 9s are all perfectly valid integers. From your perspective, an integer is just any valid number without a decimal point. That makes sense? Floats. A floating point number, which is often called a float, is any number that contains a decimal point. There's no size limit, so 1.1 or -1.1 or 12345.6.78901234.5 are all valid floats. But if you're working with very large scientific numbers, you can put an E in the number to indicate a power of 10. For example, 234E1000 is a valid number, and it's treated as a float even though there's no decimal point. If you're familiar with scientific notation, you know that 234E3 is 234,000. The E3 is just 3 zeros. If you're not familiar with scientific notation, don't worry about it. Complex numbers. So if you know much about complex numbers, these bizarre little charmers always end with the letter J, which is the imaginary part of the number. If you have no idea what we're talking about, you're normal. Only people deep in math land can care about complex numbers. All right, words. So now we're getting to the second data type. So we talked about the first data type, which is numbers. Now let's talk about words, which are strings. Strings are the opposite of numbers in a way. With numbers, you can add, subtract, multiply, and divide because numbers represent quantities. But strings are for everything else. Names, addresses, all kinds of text you see every day would be a string in Python and in computers in general. It's called a string because it's a string of characters, like letters, spaces, punctuation marks, and maybe some numbers sometimes. To us, a string usually has some meaning to humans, like a person's name or address. But computers don't have eyes to see or brains to think or any awareness that humans even exist. So to a computer, it's just a piece of information that you can't do arithmetic with. It's a string of characters. Unlike numbers, a string must always be enclosed with quotation marks. So if you don't enclose them with quotation marks, it often will result in an error or something like that. And a number, if you want to multiply and add with it or do any other operation with it, you can't enclose it in quotation marks. So you just got to remember this. So here are a bunch of valid strings. And you can use double quotations or single quotations, but you just have to keep them consistent within the same string. It's fine to use numeric characters, hyphens, dots, and periods in strings. They're all still strings as long as they're inside the quotation marks. Just be careful if you need a quotation mark in your string. So sometimes like here, if you have Mary's dog said woof, well, you have a single quotation for Mary's, but I would put that string in a double quotation. But let's say you had the other way around. If you did it like this with all single quotes, your computer will mess it up and think that you terminated the string after these two. So see the first quote sign, and then after the next one, it wouldn't know what to do with the rest of the stuff, and you'd get an error. So here is the same way. If the dog of Mary said woof, and you would put the double quotations around woof. So it's a little tricky sometimes when you have to work with these quotations. If you have like a situation where you can't even fix that, you can do something called an escape character, and this is important to learn. Escape characters basically let you escape out of the situation. So if you press backslash, that's usually the sign for an escape character. So you can do everything normally if you press backslash. So here, you don't want this quotation. Let's zoom in a little bit because this is so important. You don't want this quotation to end the string, right? You want the string to end here where it's supposed to. But the computer doesn't know that this quotation is a special quotation. So how do you make it a special quotation? You put this backslash. And you're going to see that quite a lot. We'll get to lists and tuples in a second. All right, so backslash n is the new line. So that's another sort of important escape character. So sometimes you want to have like an enter, right? A new line. So just backslash n is a good way to do that. So when you display the old pawn backslash n, a frog jumped in backslash n kerplunk, it will look like this, which is a lot better. So each backslash n was converted to a line break. All right, so we've got numbers, we've got strings. Now let's talk about booleans. The third data type in Python isn't a number or a string. It's called a boolean after George Boole, and it can be one of two values, either true or false. It may be seeming odd to have a data type for something that can only be true or false, but it's very efficient because it's just a single bit, the smallest amount of storage in a computer. So in Python, you can store true or false in a variable. For example, let's look at this one, x equals true. Or maybe x equals false. True and false are Boolean because they're not enclosed in quotation marks. Normally, a string has to be enclosed in quotation marks, but this isn't a string, it's a Boolean. And it's certainly not a number. So the initial capital letter is required. You can't do it lowercase, like in JavaScript. Capital T, capital F has to be written that way. True, false. All right, let's talk about operators. Operators are not data types. So we covered 3 data types: strings, numbers, and Booleans. Operators are a little different. It's helpful to think of information as being one of the following data types: number, string, or Boolean. You also use computers to operate on that information, meaning you do any necessary math or comparisons or searches or whatever to help you find information and organize it in a way that makes sense for you. Python offers many different operators for working with and comparing types of information. Let's summarize them for future references without going into great detail. Whether you use an operator in your own work depends on the types of apps you develop. Let's just see what's available. Arithmetic operators. So these are for doing arithmetic. Here they are. Add, like 1 plus 1 is 2. Subtract, like 10 minus 1 is 9. Multiply, which is this asterisk. 3 times 5 is 15. 3 asterisk 5. Division. 10 divided by 5 is 2. Modulus, so this is the remainder. So 11 mod 5 is 1 because 11 divided by 5 is 2 remainder 1. So the 1 is the remainder. Exponent is double asterisk. That's very different from some languages. 3 asterisk asterisk 2 is 3 squared, which is 9. Floor division. This is division with the non-remainder part. I guess it's called the dividend, I think. 11 / 5 is 2. So again, we went through all of these. So integer division, anything after the decimal point is truncated. And it does not round. So 9 divided by 5 is 1, not 1.8 and not 2, but just 1. All right, so there's some comparison operators. Comparisons can make decisions as part of doing their work. But the decisions aren't judgment calls, they're just specific absolute facts, and here are the comparison operators. Less than or equal to, greater than or equal to. Notice this one, equal to, which is double equals. To make a comparison between two things, you have to use double equals. Exclamation point equals is not equal to, and again, you have to have two things. You have to have something on the left and something on the right. These are comparison operators. They compare two things. Object identity is, and negated object identity is not. The first few are self-explanatory. We won't go into details. The last two are tricky because they concern Python objects, which we haven't talked about yet. We don't want to talk about them just yet, so don't worry about that. The Boolean operators, they work with Boolean values like true or false. So or, and not. Or has a natural language, either x or y is true, and means both have to be true, and not is the negation. X is not true, not x. So always put white space around operators. You want to use space bar before the operator and after. Here's a simple example. Num equals 10. We put a space before num, after num, and then before equals, and then also after the equals and before the 10. Num equals 10. We did the same thing here. If num is greater than 0, print positive number. Else, print negative number. That kind of makes sense. We store 10 in this variable named num. If we'll check to see if num is greater than 0, that's the comparison operator. If it is, it'll print positive number. If it's not, it'll print negative number. So if we change this code to say num equals -1, it'll print negative number because it'll check, is the num greater than 0? No, it is not. It'll print negative number. Num is a variable name. Operators will operate on the variable and compare the variable to this, the number, which is sometimes called a literal, because it doesn't change. A variable changes, a literal doesn't. So is the num greater than 0? In this case, it's yes, it's 10. All right, creating and using variables. Variables are a big part of all computer programming languages and Python. A variable is a placeholder for any information that may vary or change. Once again, a variable is simply a placeholder for information that may change. For example, when you go to Amazon's homepage, you see your name right there, right? This guy's name is Alan. And the date you became a customer. Customer since 1996. Wow, OG. Both of those pieces of information are variables because it depends on who signed into Amazon. If I sign in, it'll say Martin. That's a variable. Not everyone who goes to Amazon is named Alan and has been a member since 1996. Amazon can't make a custom homepage for every one of its users. Most of what's on the homepage is literal. Everyone views it will see the same stuff, but the information will change depending on who is viewing the page, and that information is stored in a variable. For example, like name. In your code, a variable is represented by a variable name rather than a specific piece of information. Here's another way to think of it. Anytime you buy one or more of a type of product, the extended price is the unit price times the number of items you bought. In other words, quantity times unit price is extended price. Quantity and unit price are variables because no matter what numbers you plug in for quantity and unit price, you get the correct extended price. If you buy 2 turtle doves for $1 a piece, your extended price is $3, 3 times 1. If you buy 3 turtle doves. If you buy 2 dozen roses at $1.50 per rose, it's $36, because 1.5 times 24 is 36. So variable names have specific rules. A variable name must start with a letter or an underscore. After that, you can use letters, numbers, or underscores. Variable names are case sensitive. Variable names cannot be enclosed in quotation marks. You should only use lowercase names in variables and an underscore to separate the letters. You can also use camel case. Camel case is something that looks like this. You don't have any underscores, you just capitalize new words. Some people really don't like camel case. So to create a variable, this is really interesting, and now you're going to be a real coder. You can type variable name equals value. Variable name is the name you make up, like age or name or whatever. You can use X or Y. Some people do. I wouldn't do that though. I would use names like quantity, unit price, sales tax, username, so you can remember what's going in there. The value is whatever value you want to store. Remember the 3 data types you learned: number, string, or boolean. And this is maybe the most important thing of the night. The equal sign is the assignment operator. Drill that into your head. The equal sign is the assignment operator. It assigns the value on the right to the variable on the left. It is not a comparison operator. The comparison operator is equals equals. This does not mean is x equal to 10. No, this means we're taking 10 and we're putting it in the variable x. We're assigning the value 10 to x. X is the assignment, equals is the assignment operator. User underscore name equals Alan. We're assigning Alan, the string Alan, into a variable named username with an underscore. So we can manipulate variables. That's what most of computer programming is about. It's about storing numbers or values of any kind in variables and then manipulating the information with operators. I really want you to use this term a lot. There's operators and variables. Let's try some simple examples. Quantity equals 10. Unit price equals 1.99. Let's go here. Extended price equals quantity times unit price. So that's 10 times 1.99, right? So let's try print extended price. Let's see what happens. It prints 19.99 because there were 10 things at 199. What if I made it 100 things? Would that work? There it is, 199.0. What if I change the price? What if I jack the price up to $50? That should be the new price, right? Python, run the file, and now you have $5,000. That's how you make real bread, but that's a whole other story. We raised the price. Say it was $18 before, and you're selling 2,000 pills. Quantity, let's change that to number of pills. Unit price was what, $17.50? We got to change this here. Number of pills. And let's run that again. And you can see the revenue was $35,000, but we want to change that. Let's change that to $7.50 unit price. And now the revenue is a lot more. It's 1.5 million, right? That makes more sense. How do we run? Right-click hello.py. Oh, you already know CUIU perk. And run Python file and terminal. The shortcut. What do you mean? All right, so that's is there a shortcut for terminal? It's control backtick or control tilde, which is right next to your number 1. All right, so you can save your work, right-click hello.py and hit run Python file and terminal, and everything works out. So you can just change the number instead of changing the whole app. Proper syntax is important in programming. I think you guys know that. You have to do variable equals value. You can't do value equals variable. 10 equals x does not work. You'll get an error message. You got to follow strict syntax rules. That's what makes programming a little bit hard sometimes. The computer can't understand what you mean, right? In Python, a line of code ends with a line break or a semicolon. Let's try this example. Interesting. First underscore name equals Sarah. Okay. Last underscore name equals Shkreli. Okay. Now we're going to print first name, last name. Let's run this program. We're going to see Sarah Shkreli. But if we wanted to, we could put this all in one line with a semicolon, and we'll get the same result. And in fact, if we really wanted to, we could put everything on one line with another semicolon, and we'll still get the same result. Notice the variables have 2 words separated by an underscore. Again, that's the Python convention. You can also do camel case, which would look like that. If you really wanted to, you could do it like that, but I don't recommend that. Don't start a variable with a capital letter, only in certain scenarios. All right, so code blocks, very important. So let's again look at x equals 10. Now we're going to do if x, and remember, equals equals is the comparison. This does not mean assign 10 to x. That's what this line is. This means, does x compare, and how does it compare to 10? And we're going to use the colon. Isn't that weird? You put the colon down, and then you have to indent. You can press tab to indent. And we're going to type print x is 10, if that's true. And we can also change it to 0, and we'll say, well, x is 0. But I can also write whatever I want. I can write x is the moon landing, and this will run and print the moon landing, because the program isn't necessarily smart. It's only as smart as you are, right? So I can have completely legal code but it doesn't make a lot of sense. It says, well, if x compares and is equal to 10, it'll print x is the moon landing. But I can also make a mistake and say it can print x is 9, and this will still print because it is just the string. But notice what I did down here. It'll print x is, and then it'll actually print x without the quotation marks. We're referring to the variable x. So let's see what happens if we run this. I run it and it'll say x is 10 because it looked at x and said, well, is x equal, not assignment, but is x equals to 10? Equal? Yes, it is. So it ran this. And if I change this, there's no logic in here. I could say x is 9. It will still run and say x is 9 because it's just going to print whatever. I could say SBF is innocent, free my dog. And it'll run, and that's exactly what it'll say. It'll say what it said, even if it's wrong. It'll say exactly what you want it to. There it is. Now let's change x is 10 on the assignment operator to 9. So x equals 9. So this is false. X is 9. 9 equals 10? False. So it'll go to else, and it'll print x is, and notice it'll print what's inside of x, which is really cool. And it printed 9. And it printed 2 spaces, so I deleted one of the spaces, and now it prints that space perfectly. So if I put 5 in here, it'll print 5. If I take out this x, what do you think will happen? Will it print out the value of x? No, because I deleted it. So it just says x is. If I wanted to, I could write something like x is not 10, which is true because x is 5. So it'll type x is not 10. If I change it back to 10, it'll go back up here, make the comparison, and say, okay, that's true. So x is 10. If I change to x is 100, x is not 10, so it'll go to else and print x is not 10. And I also change it to say x is not 10, but it is, and then I do comma x and print x. So it says x is not 10, but it is 100, because it looks at what x is. So this is how you play with variables in Python, and this is going to be really, really, really important as you learn Python. The 2 equal signs means is equal to in Python. It's used to compare values to one another to see if they're equal. That's different from just 1 equal sign, which is the assignment operator for assigning variables. The first line, x equals 10, is just a line of code. Next, if x equals 0, test to see whether x contains the number 0. If it does contain 0 and only 0, the indented line, notice the indent, will run. It'll execute and it'll print x is 10 in this case, or x is 0 if we change it around. But if it does not contain 10, it'll skip this indented line and the else statement will execute. And we can also add a final line in here, print all done, and that will print no matter what because it's not indented. But if we indented it, what would happen? It'll only print if it's part of the else. So if we change this back to 10, will it print all done? I don't think so. It did not print all done because all done is part of the else. And we know it's part of the else with the indentation. So if we remove the indentation, it'll print all done. So indentations matter quite a bit in Python. You'll learn about the specifics of indentation as you progress through the book. For now, just remember that indentations are very important, so be careful when you write them. Wow, we're 80 pages into this book. It's only 700 pages, so we're doing great. Okay. The exercises you've just completed explain how to type, save, run, and change an app, save it again, and run it again. That's all you'll be doing with any kind of software development in any language, so you should practice them until they become second nature. But don't worry, you don't have to do this one chapter over and over to get the hang of it. You'll be using these same skills throughout the book as you work your way from beginner to 21st century hotshot developer. So that's it for book 1. We did great. Congratulations, everyone. There's only 7 more of these, so we did 1/7 of a whole Python book. Really impressive. Book 2, maybe we'll do some other day, is called Understanding Python Building Blocks. And again, it's only 6-7 chapters, so it's like similar to the first book we just read. And again, I know that maybe you don't feel like you have a ton of skills just yet, but Rome isn't built in a day, and it takes a little time, and hopefully I whet your appetite a little bit. I do think learning Python is really important. I think it's crazy if it's 2023 and you don't know Python. You should really learn it. It's really easy, and it's become really, really valuable. And there's a lot of important things you could do with Python. So I really strongly suggest you do learn it. And this book is pretty good for a beginner's book, but there's other books, of course. And you could read any of them. It doesn't really matter. You can also don't even need a book. You can go on YouTube. You can watch this. You can go anywhere and learn Python on YouTube, on different websites. There's boot camps. There's free ones. There's all kinds of paid ones. There's all sorts of lessons to learn Python. And I think it's really, really important to do so. Get my OCD checkmark thing. But yeah, thanks for joining. I hope you guys learned something. You know, this was the contents. We did starting with Python, interactive mode, Python elements and syntax, and we built a very basic app. Let's take a look at book 2 really quickly and see what's in store for us when we do look at it. We're going to work with numbers, text, and dates, controlling the action with if, for, and while, real programming here, lists and tuples, dictionaries, and then functions, classes, and errors. So this is like almost 200 pages, and it's like the really, really, really big parts of computer programming. Whole numbers, decimal points, strings, booleans, dates, and times. So this is the first chapter. And again, there's a lot to this, so we have a lot to do, and this probably would take maybe 6 hours or so, maybe more. So this is a really big book 2. But I do think it'd be worth your time. And again, it's not too painful. You know, we did book 1 together. We can do book 2 together. This is like the bulk of the book. I wonder what book 3 is. Yeah, this is book 2, so I wonder what book 3 looks like. Let's take a look. I like skipping ahead sometimes. It gives me motivation. Book 3 is working with libraries. And that looks a lot shorter, so that's maybe like 80 pages. So that would take like 3 hours maybe. Pretty simple. let's look at book 4 as well. Book 4 is using AI. So we're basically done with Python after book 3. Book 4, neural networks, machine learning, and AI. So this pretty quickly moves on to some cool stuff here. So this is a nice book for that reason. You get a taste of AI really quickly, which is pretty cool. And it's real AI. Like there's a lot of details in there that are really cool. Book 5 is data science. Short, really short, 40 pages, maybe take an hour. Book 6 is about hardware, which I would probably skip. This is for working with Raspberry Pi, which is a really unique tool. Not something I think we necessarily want to do. If you want to do that, that's all you. I think book 7 is robots. Again, if you like that kind of stuff, that's great for you. Book 7. So I only would read half of this book. But if you like robots, go for it. Nobody's going to stop you. And you can even use AI with robots. So I would skip chapters 6 and 7 for me. And then that's the end of the book. So really short book, to be honest. I think we can hammer it out in a couple more videos. And then we could read more complicated books about Python. So I hope you enjoyed that. You get a little taste of what Python's all about. A lot of talking, sometimes I get a little winded. Now I need to smoke some weed. And please visit Dr. Gupta. This message is brought to you by Dr. Gupta, an AI physician. Nibbles? Mrs. Nibbles? Oh, hey! Somebody's asking about you, Nibbles? Somebody's asking about you, Miss Nibbles. Aren't you so beautiful? Yes, you are. Yes, I love you, my Princess Nibbles. Yes, I do. I love you. Now she's closing her eyes. Yes, I love you, Mrs. Nibbles. Yes, I do. I love you. Chin scratches for my queen. Meow, meow, meow. Meow, meow, meow. I love you. I love you. Meow, meow, meow. When you scratch the chin, you have to make sure you don't scratch the whiskers, too. You're just right in there, right behind the whiskers, and just gentle little scratches. Meow, 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 I love you. Yes, I do. Meow, meow, meow. Meow, 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 I love you. Yes, I do. Kitty, poo-poo. Eventually, she just starts to bite me. She's already a 10x programmer. She yells at me when I don't use TypeScript. Right, Kitty? Right, Kitty? I'm a little kitty. Oh, stretchy, stretch, yeah. Margin of safety? Great, I'm glad you read it. Not everyone reads it. Everyone recommends it, but nobody reads it. Google Analytics. Let's go. How many people are on Gupta right now? Whoa! Holy moly, there were a lot of people. Indonesia, India, Philippines. Wow. We went viral in Indonesia for some reason. Sounds like a rock band name. Viral in Indonesia. Well, it is the next day. Let me see if we... May 8th is yesterday. I suppose I should upload this video, but I need some help with social media. I need like a full-time person who like comes to my office or my home and works every day on social media, uploading, editing, shooting, doing skits. My buddy Poops and I are probably going to do a podcast, but we need somebody who's good with all that stuff. Probably work out of our office. No remote. And Poops is really funny. You guys are going to enjoy him. Right, Kitty? Right, Kitty? You're a little Poops. You're a little poo-poo. Scoop-poo-poo-poo. My baby. Do we log the IPs at Dr. Gupta? Sure. Our server logs everything. What's the secret sauce? I don't know. Some days I feel like I look older. Oh, Scoop-poo-poo-poo, I love you. Yes, I do. I took a nap earlier and she curled up right next to me. Right next to me, right? Right, my little love? Right next to me. That's how I know she loves me, right? That's how I know. When she wags her tail like that, that's how I know. Maybe I'll write a book one day. I work from the home and an office. Sometimes from home, sometimes from the office. Depends. Yes, I love you, Kitty. You're so good. You're my best friend. You're my best friend. Purr, 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 purr. Purr, purr, purr. Best thing I eat in prison. The food sometimes isn't that bad. It's usually pretty bad. I'm not much of a foodie anyway, so. No hair dye for me, no. And when I go gray, I'm going gray. You can probably see a couple of gray hairs there. My beard's pretty gray. But yeah, my you can prove technical analysis doesn't work using backtesting. I don't typically have dreams about prison, but I think I've had one or two. Nothing too bad though. No nightmares or anything. How to meet Kanye West. Be prepared for anything. Kanye is known for being unpredictable and eccentric. That is definitely true. Kanye's the homie for real though. Times change. Druckenmiller. Good, I'm glad NALM. Top 5 entrepreneurs of all time. Dylon. Nibbles, 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 nibbles. Spit hot fire. Spit hot fire. Yes, I do. Yes, I do. Oh, she's so tired. She's so lovely. Yes, 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 I love you. Yes, I love you. Time is moving too fast, too slow. Crypto, crapto. No, we don't bring Kitty into the office. We should. We definitely should. What's up, my little Snoopy? Yes, I love you. Yes, I do. Can't believe Twitter banned my new account. Like, what the fuck? I don't play League. I'm starting to get tired. I want to go to sleep. Voldemort. Yeah, I don't like trading unless it's a binary event. All right, yeah, it's midnight here. Great talking and hanging out. I'm gonna relax. If you do want to come hang out, I'll be on Discord for probably at least another half an hour, and you can check out that. But I'm gonna take it off for now. Have a great night. See you guys soon.